And this section is looking at like divisibility and prime factorization. So I want to just start out with kind of like what do they mean by something's divisible? Because you can really divide anything by any number but 0. But officially it's divisible if you do a number divided by a second number and it leaves an answer that doesn't have a decimal. Or leaves, the way you did it before is no remainder. And by that, basically, you could say no decimal. Oops, I must have hit a different button. No decimal in the answer. And so just to try to clarify, I put this example 1 in there, like 6 divided by all these different numbers, just to kind of show like what do we mean when we say divisible. Because if you do 6 divided by 1 is just 6, agreed? So is 6 divisible by 1? Yup, because we get an answer that doesn't have a decimal, there's no remainder, there's nothing left. 6 divided by 2 is 3. So 6 is divisible by 2. You get an answer with no remainder. You don't get a decimal answer. 6 divided by 3 is 2. So is 6 divisible by 3? Yup, because you get an answer with no remainder. You don't have a decimal in your answer. 6 divided by 4, though, is 1.5. So it's officially not divisible by 4. 6 isn't divisible by 4. 6 divided by 5 is going to be 1.2. So you get that 0.2, or you get a remainder. You have a decimal in your answer, so that's not divisible by 5. 6 divided by 6 is 1. So we could then say that 6 is divisible by 1, 2, 3, and 6. Or the other way to write it is the factors of 6. You guys learned about factors last year? So factors are what numbers you can divide something by. Maybe I'll write that down too. But factors of 6 would be 1, 2, 3, and 6. And maybe we should go and define the numbers that this thing here, that second number, those are going to be called the factors. And maybe I'll say equals the numbers something.
Do you want us to write that?
I would write it is divisible by. So our factors ended up being these numbers here that worked out. You know, we had 1, 2, 3, and 6. So hopefully you can squeeze yours in using the margin a little better than mine. Fortunately, there's kind of some rules that can help you determine just by looking at a number if it's going to be divisible by different things. So I filled in some of the stuff for you, but we're going to say a number is divisible by 2 if it's, what kind of numbers can you divide by 2?
Less than 2. Even?
Even, nice, if it's even. So any even number, 24, you can divide it by 2 because it ends in 4. So even numbers, anything that ends in a 0, 2, 4, 6, or 8, right? So 436, can you divide it by 2?
Yes.
Yep, because it ends in a 6. 4,362,709.
No.
Because it ends in a 9, it's odd. Okay, we okay for the 2?
Yes.
For the 3 would be if the sum of its digits, when you see the word sum, do you know what that means?
Yeah.
You take all the numbers and you add them. Perfect. So sum means add. So if the sum of its digits is, I'm going to do a little divided by sign, it's divisible by 3. And what I mean by that, so I have this example 204. What we're saying is 2 plus 0 plus 4. 2 plus 0 plus 4 equals 6. So what you do is you take all the numbers in the number and you add them together. So I have 2 plus 0 plus 4 is 6. Can I divide 6 by 3 or 6 divisible by 3?
Yeah. Yes.
Yep, so it's divisible by 3 because I can do it and I get a 2, an answer without a remainder. So 204, is that divisible by 3?
No.
Yes, because the sum of its digits is divisible by 3. Then you know the actual number itself is divisible by 3. 4. 4, well, 1, it has to be even, but that'll work about half the time because some even numbers aren't divisible by 4. Like 6 isn't divisible by 4. But if the number in the last two digits is divisible by 4. So what I mean by that is if I have this 4,852, you can totally ignore the 4,800. Because do you agree 100 is divisible by 4? I think of like a dollar, 4 quarters are in a dollar. So anytime you have a multiple of 100, this 4,800 is 48 hundredths. So we know that's going to be divisible by 4. All we have to worry about is this 52. So really, for this one, you're just saying 52 divided by 4. Does that work? And at first, it's kind of like, well, I can't do that easily in my head. But what's a number less than 52 that we know is divisible by 4?
8.
Not 50, but
51.
you're thinking way too hard. 40, right?
Oh.
Do you agree 40 you could divide by 4?
Yeah.
So we know 40 divided by 4 works. 52 is 12 more than 40, right?
Yes.
Is 12 divisible by 4?
Yes.
Yeah, yep. So this one here, 4,852 is divisible by 4. If I totally lost you there, I'd be glad to go over it later. Push comes to shove, you do it the old-fashioned way. 4 goes into 5 once, then you take away 4. You have 12 left. 4 goes into 12 3 times. So if I do kind of the long division there, I get 13 for an answer, and I don't have like a remainder or something because it gives me a 0. We okay for number 4?
Yep.
Okay, we'll pick up the pace on some of these other ones. 5. If the last digit is what or what?
0 or 5.
Perfect, 0 or 5.
Wow.
Because multiples of 5 go 5, 10, 15, 20, 25, 30, 35, 40. So it has to end in a 5 or a 0 to be divisible by 5. Number 6. 2 times what is 6?
3.
3. So because 2 times 3 is 6, if a number is divisible by 2, and divisible by 3, it's going to be divisible by 6. We could take and maybe shorten that a little bit, which kind of hoses the pen users. But we know something's divisible by 2 if it is even. That was our thing up here. So for this one, you could say 6 if the number is divisible by 2 and is divisible by 3. Or instead of that divisible by 2, you could get rid of that and say instead that if the number is even. You could just do that instead of divisible by 2, but either one would work. So pick whichever one you prefer. Number 7, there is no good rule for 7. If you come up with one, maybe people will give you a lot of money, or at least you'll become popular. But so typically in the homework, we're not going to ask about 7s. We just won't do that. Number 8, if the last 3 digits are divisible by 8. And that seems a little rough. We'll kind of come back and look at that kind of like we did the 52 divisible by 4. So we can kind of hack those apart. Number 9. If 9 and 3 are kind of related, does that make sense in your brain that 9 and 3 are kind of related?
Yeah.
Because like 3 squared is 9, or 3 times 3 is 9. They're both odd. So the rule for 3 was if the sum of the digits is divisible by 3, 9 is going to be if the sum of the digits is, any guesses?
9.
Yep, is divisible by 9. So we'll, on our examples that we do, we're going to do the same sort of thing starting out as this, where we do 2 plus 0 plus 4. But then we say, okay, is that divisible by 9 instead of is it divisible by 3? Okay. And 10 is divisible by 10 if it ends with a 0. So if you think of multiples of 10, that's all the stuff that's divisible by 10. 10, 20, 30, 40, 50, 100, 110, 120, they all end in 0. Okay, so if we were to go up to this one here, and I maybe should have left a little bit more space, but could say is divisible by... I'm going to start at the low numbers, but you're right, 10 will work also. But will 2 work, yes or no?
Yes.
Yep, so 2 works. How about 3? To figure out if 3 works, we do 4 plus 3, 2. So 4 plus 3 plus 2. 4 plus 3 is 7, plus 2 is 9. Is 9 divisible by 3?
Yes.
Yep, so we're doing this thing here. If the sum of the digits is divisible by 3. So 3 works. For 4, we look at the last two digits. Are the last two digits divisible by 20? Last two digits divisible by 4. The last two digits are 20. 20 divided by 4?
5.
5. So it works. So this one's divisible by 4. Is it divisible by 5?
Yes.
5. I was going to say 50. 5. Because it ends in a 0, so 5 works. 6. Yes, no?
No.
Yes. Because?
Zero's even.
Perfect. Yep, it's divisible by 2 and 3, or because it's an even number and it's divisible by 3. If 2 and 3 show up, then 6 automatically shows up. 7, no good rule. Let's ignore it. 8. If the last 3 digits are divisible by 8. So 320. My first thought was like, okay, 320 divisible by 8? That's only a little bit better than 4,320 is divisible by 8. But,
You can 8 goes into 32.
ooh, beautiful. Yep. That if we have this 320, if you're looking at 32 divided by 8 is going to be 4, yes?
Yes.
So 320 divisible by 8 is going to be 40. So exactly, Olivia totally nailed it. And other people helped her. So it is divisible by 8. And then 9, the sum of the digits is divisible by 9. So we're doing this rule here. So 4 plus 3 is 7, plus 2 is 9. Can you divide 9 by 9?
Yes.
Nice, so 9. And then last but not least, 10.
Yes.
Yep, because it ends in a
0.
0. Perfect. Our next one, we're not going to have as many numbers. 845. Can we divide it by 2?
No.
No, because it's not even. So I'm maybe just going to put in a 2 and just cross it out. How about 3?
Yeah.
Because 8 plus 4 is 12. Plus 5 is 17. Can you divide 17 by 3?
False.
Nope. It'd be like 15 and 18 you could. So 3 is not. How about 4? 4, the last two digits are divisible by 4. But do you agree every number that's divisible by 4 has to be even? So because this baby's odd, you don't even have to worry about the rule. Because only even numbers can be divisible by even things like 4 and 6 and 8. So you totally can skip 4, 6, and 8 with any odd number. But if you were to do the rule, can you divide 45 by 4?
No.
No, because 44 you could,
Yes.
and 40 you could, but 45 couldn't. So not 4. How about a 5?
Yes.
Because,
And do the 5.
perfect. 6 is if it's even and divisible by 3.
No.
Nope. Because it's not even and it wasn't divisible by 3. We crossed out the 3. 7, skip it, there's no good rule. 8, do we have to check the rule for 8?
No.
Because it's,
Even.
yep, 8's even, or numbers odd. Or you could do the last, you could do the last digits. But okay, how about a 9?
Yes.
Does 9 work? So 8 plus 4 is 12, plus 5 is 17. Is the sum, is the 17 divisible by 9?
45.
Ah, but 9 times, well, the 8 doesn't work out. Yeah. 9 was,
9 times 6.
if you would take a calculator, do the whole 845, it would work. The reason the 45 works for the 4 is because 100 is divisible by 4, so any multiple of 100 is divisible by 4. But you agree 100 isn't divisible by 9? Because 99 would be, and 108 would be. But so 9, you have to go back to your rule. So sum of the digits, 17, can't divide 17 by 9, so 9 is not. How about 10?
Yeah. No, it doesn't have the
So the only one that worked was a 5. And 162, divided by 2?
Yes.
Yep. How about 3?
No.
Because 1 plus 6 is 7, plus 2 is 9.
Oh, it can.
So it works. Should we right away just put the 9 in there too? Because you agree, add them all up. Can you divide by 3? Yup, it gives you this. Can you divide by 9? Yup, it gives you that. Ooh, so 6 works. Because 2 and 3. All right, now we need to go back to the other way. So the 4. Are the last two digits divisible by 4?
Yeah. No. 6 isn't. No, it isn't. No, it's not.
Nope.
But 16 is.
Because 4, I look at it as though you have multiples of 20. So 20, 40, and 60 are divisible by 4, but you get 2 extra above 60. You need to have a multiple 4. So 4 is not. How about 5?
No.
Nope, because it doesn't end in a 5 or 0. How about an 8? 8 was the last 3 digits.
No, it doesn't work.
Easiest might be just to go through and do divisible by 8. So we have a 2 minus 16, 0 and a 2. Yep, can't go in there. So 0. You have remainder 2. So 8 doesn't work. 9 we said works. Does 10 work?
False. No.
So 10 doesn't work. So then we have 2, 3, 6, and 9. Any questions before we move on? In my mind, to keep these straight, I kind of look at what's similar. That 3 and 9 are similar. They're about the same. And 4 and 8 have a lot in common. So if you kind of pair those together in your brain. 5 and 10 are kind of similar. So then if you kind of learn the 3, then it's like, oh, 9 was similar. It's easier to remember the 9. Or you remember the 4, 8 was similar. Easier to remember the 8. Okay. All right, let's do this next stuff. So the next page, we have prime numbers. Yep. A prime number is a number that is only divisible. Spelled that wrong, so I was excited because I heard somebody say what it was. Divisible by 1 and itself. So have you guys learned this before, like last year? Okay, cool. So prime numbers. We start with a 2.
There's a lot of them in 100.
2, 3. Is 4?
No.
Because you can divide it by 1 and 4, but also 2. So 4 is not. How about 5?
Yes. Yeah.
Yep, showing you can divide by 1 and 5. 6?
No. Yeah. No.
Nope, because you can divide it by 2. 7?
Yes.
Yep. 8?
No.
Nope, you can divide by 2. 9?
No. Divide by 3.
9 you can divide by 3. 10?
No. No.
Because you can divide it by 2 also. 11?
Yes.
Okay. 12?
No.
Do I have to do any of the evens anymore?
You don't do any evens, I don't think.
Perfect, because all the evens are divisible by 2, right?
Yeah.
So we can just skip the evens. So no 12, 13.
Yeah.
13. So skip the 14, 15.
No, it can be divided by 5.
Nice. And should we just do dot, 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 or are you kind of having fun?
Yeah. I like this.
You can do dot, dot, dot. It is kind of fun, though. So 16 does work. 17.
Yes.
17 is prime. 19.
Yeah.
Yep.
Yep.
Then they start getting really scarce. So 21.
No, divided by 7.
Perfect. 21. 23.
Yes.
23 would be a yes. 25. No, none of the 5s. 27.
No, because 19.
Ooh, nice, because it's divisible by 9 or by 3. 31. Wait, do we do 29?
No.
29 would be, right?
Yeah.
Okay, my notes have 29's. Okay, we should just move on because some of you are like, yeah, whatever. Notes are taking way too long. Composite number. Composite number are a whole number. By that we mean no decimal. So no decimals. With more than 2 factors. Because prime numbers are going to be divisible by 1 and themselves. So this needs to have more than 2 factors to be a composite number. Fair enough? I suppose, though, you could say, I'll just move on. I'll just move on. More than 2 factors. So 12. If you're looking at 12, one of the ways people have done this is they've done like the rainbow method, they called it. Because 1 times 12 gives you 12, right?
Yep.
So 1 and 12 are both going to be factors. I've heard it called the rainbow method because, those are kind of connected. Can you divide 12 by 2?
Yes.
And 12 divided by 2 is?
6.
6. So it's kind of like 2 and 6 are kind of like connected. Can you divide 12 by 3?
Yes. 3 and 4.
Yep, 3 and 4. So 3 and 4 are kind of connected. So you're done. You kind of met in the middle. So 12 has 6 different factors. So 12 has to be a composite number. Where if you have the 7, you have 1 and 7. Agreed? So 1 and 7. And divide by 2, nope. Divide by 3.
None.
Nope. 4. Nope. 5. Nope. So 7 is going to be prime. So I could say this one here is prime because it has only 2 factors. 12 then, kind of covered it up, but 12 is composite because it has more than 2. In this case, it has 6. So we hit that. Now we're down to kind of our last thing in here. Okay. Our last thing looks at how could you take a number and break it up into just what prime numbers times each other give us that number. Do you guys remember doing factor trees?
Yeah.
Okay, so this is repeat 2. Okay, cool. So I'm going to say uses a factor tree. So uses a factor tree to break a composite number into prime numbers. And some people do these different ways, or people do these different ways. Some people like to take the 154 and think of what are some big numbers I could divide it by. For me, I just do small numbers, but it's really up to you. I look at 154 and I say it's even, so I know it's divisible by 2. And then I say, what's half of 154? Well, half of 150 is going to be 75, and half of 4 is 2, so it'd be 77. Can I convince you of that?
Why not like that?
Yep, you kind of just keep breaking it apart.
Yeah, you do like the triangle. 2 is like the triangle.
Yep.
Yeah.
So 77 is divisible by
11.
11 and 7. I'm going to put my 7 first. I like doing small numbers first, but it doesn't matter too much. So now we're down to all prime numbers. All those 3 numbers, the 2, the 7, and the 11, are listed up above. So the final answer, the way they write it, is 2 times 7 times 11. Those are the prime factors. Questions on that one?
Nope.
All right, so 63. We could divide 63 by
9 and 7.
9 and 7. Okay. I'm going to put my 7 in front because that's a prime number, but that's personal preference. You don't have to do it that way. But we can't divide 7 up anymore. But 9 we could break into
3.
a 3 and a 3. So my prime numbers are 7, 3, and 3. You could write 3 times 3 times 7, but usually they write 3 squared times 7. You guys used to 3 squared as being 3 times 3?
Yeah.
And I have 2 of those 3s that are multiplied, so 3 squared times 7. It's kind of the final answer there. Very last one, 630.
2 times 3 is 15.
Nice, 2 and 3, 15. Good. So 2 is a prime number. I'm going to circle it right away. 315 I could divide by
5 or 10. No, 5.
5. Now that one gets a little tougher, but 5 goes into 100 how many times? Well,
25.
you could use a calculator, I suppose, for this too, but it goes into 120 times. So if I have 300, agree that's going to be 20 for my first 100, 20 for my second 100, 20 for my third 100. So 60, just in that 300. How many times does it go into 15?
3.
Yep, 3, so 63. So I have 60 to get my 300, 3 more to get my 15. But if I'm just trying to show you how to do it in your head. I think that's kind of fun. Okay, 63 I heard a 7 and 9. And 9 is 3 and a 3. So now to write our final answer, you go through and, well, 2 is my smallest, so I do a 2 times. And I have how many 3s?
2.
So I do 3 squared. And then I do times 7. And that's the final answer. 2 times 3 squared times 5 times 7. And please do put them in order, smallest factor to largest factor, and do the exponents. That's it. So a huge section of notes, but let me know if you have questions.